Okay, so question 1A is asking for the period for a lasso that has a length of 2.5 meters. So we have a length of 2.5 meters. And if you recall, the formula period equals 2 pi. Square root of your length in this case is 2.5. And the rate of gravity, which is 9.81. Now keep in mind the definition for period is to complete one cycle. The question's asking for 3 cycles, so it's kind of a trick question how it's phrased. Now my calculator is a little different here, but the square root of 2.5 divided by the rate of gravity is 0.5. Now we multiply that against 2 pi, and our answer becomes 3.17. Keep in mind this is in seconds. Now in preparation for the following questions, we might just want to convert this into frequency. So in this case, your frequency is going to be 1 divided by your period, which is 3.17, which comes out to be 0.315. And this is in hertz. Now 1B is similar, but now we have a different length. In this case, our length is now 3 meters. So go on with the period of 2 pi, square root of 3 divided by gravity, multiply that by 2 and pi. We have a period of 3.47. Now let us find the frequency as well for this. So 1 divided by 3.47. And we have a frequency now of 0.28. And we'll go keep the thousands as well. Now this question is asking for the difference in frequencies. Your original frequency was given as 0.315 hertz, and the secondary frequency is 0.288. So we subtract these two numbers to find the net difference. So 0.027 hertz. And that should be the final answer for 1B. Now part C is asking for the total distance covered for both lassos. This is relevant to your circumference. So circumference is 2 pi r. Your r, as I said earlier, is based off the length of your pendulum. Now one length was 2.5, and we completed 3 cycles. So your circumference would be 2 pi 2.5, and you completed 3 total cycles. Which get So we have about 47.1 meters. Now for the second lasso, the length was 3 meters for 3 cycles as well. So the circumference so 2 pi 3 and then 3 cycles gives us 56.5 meters. You add up both of these numbers together, and you have a total of 103.6 meters. Now going with number 2, we have a few numbers in the proper units. The first one being grams, we had to convert to kilograms. There are 1,000 grams for each kilogram, so we divide 561 by 1,000, and we get 0.561 kilograms. The second number being the spring constant. This is based off of centimeters. We have 100 centimeters for every meter. So 2,600 divided by 100 gives you a new spring constant of 26 Newton for each meter. Now the question is asking us for our period. Period in this case is 2 pi and the square root of your mass, which is 0.561, divided by your spring constant of 26. This is our square root number of 0.146. Now we multiply that against 2 times pi, and we get 0.92 seconds. B is asking for the frequency. So our period is 0.92 seconds. So frequency is going to be 1 divided by your period. So 1 divided by 0.92 gives you 1.08 hertz. Now 2C was omitted or skipped. Now for 3A, I'm be told I have a pendulum of 3.6 meters, and that pendulum has an amplitude of 25 degrees for each direction from equilibrium. So we have a total angle of 50 degrees because we had originally 25 plus 25. So 25 for the left and 25 degrees for the right. Now going based on circumference, we had 2 pi and your radius was 3.6. So we have a total circumference of 22.6 meters. This is based off a total of 360 degrees of a circle. Now we only require 50 degrees for the arc. So now we have a proportion of 22.6 meters for 360 degrees equal to 50 degrees. So this might be one of the only times where we cross multiply. In this case, 22.6 times 50. And then from here we divide by 360. And we have a total arc distance of 3.13 meters. Now all this information will be relevant in the open-ended and of course in the multiple choice questions, but there will be something also added. One equation or two always come back from previous units. In this case you have delta length of your initial length, your alpha, and your change in temperature. Keep in mind this is linear thermal expansion. How does this come to effect in this pendulum's questions? Keep in mind a pendulum is connected by a string, cable, or rope. This is linear in its format. So we can expect if the degrees are raised or drop, your pendulum may decrease in length or increase in length. And also we opened the unit originally with the elastic energies. In this case is half of your constant and your delta length. We also carried Hooke's law, which is also your constant and your delta length. And bear in mind, if you have a force, forces can come in many forms. One case could be weight, which is a product of your mass and your gravity. Gravity has always been given to you guys as 9.81 meters seconds square. And that's it.